Yeah, you can see these are your fan coil units. Okay, so these are kind of regulators. So just like regulator we have for our fan. So this regulator can regulate the flow. Okay, it can reduce the flow. It can just increase the flow according to your requirement of room. Okay, so this is your fan coil unit. Okay, so according to the requirement of that particular zone, you can increase or reduce the flow. Okay, we'll see this in detail as well. Then again, you have different connections. Okay, so whenever a duct is passing, so if it is bending, so we have different connection for that. If it is transiting, suppose if your dimensions are changing for that particular duct, so in that particular portion also you'll require some connections. If there is a branch or if there is a takeoff from that particular duct, there will also be a requirement of connection. So we'll see that connections as well. Okay, so connections in duct. So let's see connections in duct. Okay, you can see there are this is your elbow connection. Okay, then you have this takeoff here. So this is kind of a takeoff. We'll discuss this as well. Okay, then we have different type of connections here. This is your shoe takeoff. Okay, shoe tap fitting you can say, or beveled fitting. This is then again you can see, yeah, these are the various type of connections. T, then you have your square and round, then you have 45-degree bends. So all these type of connections are available, and with this you can just create ducts. Okay, so whatever your routing is, whatever your alignment is, with help of these connections you can just place your ducts properly. Okay, you have flexible ducts as well. Okay, in certain types and in certain locations you will use flexible ducts. Okay, so these are your flexible ducts. So in certain locations, you will provide this flexible ducts as well. Okay, so you can see insulation is also provided here. So there are various types. Then again, you have various types of connection. So all these things are available. And these are the basic components that we can use to create our HVAC system. Okay, I hope everyone is following.
Yes, sir.
Yes, sir.
Okay, great. Okay, so now first, yes, Sanju. Okay. Okay. Now, first of all, for working in a HVAC environment, what we will need is we'll require a proper template. Okay. So for that, in our system, we have a proper template. So we have different templates. We have system templates, we have mechanical template, we have electrical template, we have plumbing template. Okay. For separate things, we have separate templates. But if we want a proper template, just like what we had is a construction template which fits all. Okay, so just like that, we have a systems default template which will fit everything. Okay, you can just work in your MEP, that is your mechanical, electrical, and plumbing. You can work in everything properly by using that default template. So let's browse and let's search for systems default. Yeah, systems default metric and open it. Okay, and now I'm opening it here. So you can see a basic environment for MEP is created here. You can see the browser is organized accordingly. You have your electrical here, you have your mechanical, you have your plumbing. Okay, MEP, mechanical, electrical, and plumbing. In mechanical, our HVAC will be there. So HVAC, we have floor plans, one mechanical, two mechanical. So this just like what we had in architectural floor plan, we have this same thing in our HVAC floor plan. So let's go in our one mechanical. So this is your level one mechanical plan. Okay. And your view settings and everything will be set according to your MEP. Okay. I hope it is clear and everyone is following.
Yes, sir.
Okay. Then here in your systems tab, you can see, so first thing or the first segment that you have is of HVAC. HVAC will consist of your ducts, then your joints, then your connections, your flexible ducts, your air terminals will be there. Then there will be fabrication parts. Then there will be your mechanical equipments. Then will be your plumbing and piping equipments. Then you will have electrical equipments, and then again you have lighting, and then you have your plane settings. Okay, so this is the basic things that are available in your systems tab. Okay, basically we will start with our HVAC system. I hope it is clear.
Yes.
Okay.
Yes.
Now suppose I am drawing a wall in here. Okay, so I'll just draw a basic wall here. I'll just go to architecture. I'll just select a simple wall and I'll just try to create a wall here. But can you see this particular wall is in gray color? Okay, and if I just try to select this wall, you can see if I'm trying to select this wall, I'm not able to select this. So can anyone tell me why is it like this? Yes, why am I not able to select this wall? Nothing.
The work plane settings.
Not exactly that. Work plane, no. Any other guesses? Anything? So I guess we have discussed this earlier in our preliminary classes.
Because it's we are doing in mechanical, sir.
Right.
It's
Right.
architectural template.
Not template, not just template. See, we are right now working in a mechanical discipline here. Okay, so that's why this architectural element is not accessible here. So now suppose if I change it to architectural maybe, then it will be accessible. Okay, but we have a particular discipline in which we can access everything. So what is that discipline? Come on guys, we have discussed this. Okay, so I can just go to the coordination discipline and I can access everything. Okay, in coordination settings, everything is properly maintained and everything can be accessed properly. Okay, it is in terms of coordination, which means it deals with every discipline that is available. Okay, and these are your specific disciplines: architecture, structure, mechanical, electrical, and plumbing. Okay, so right by default, it was in our mechanical discipline. So that's why this architectural wall was not selected. But if you just go to the coordination view, you can just select it properly. I hope it is clear. Hello.
Yes, sir.
Yes, sir.
Now, the next thing that we can see here is, so first of all, I'll just delete this wall. Okay, so I'll just create a simple plan. First of all, using my walls option, I'll just create something here. I hope I'm audible properly. There is no problem now.
Yes, yes, sir.
Yes, sir.
Okay, now suppose these are some of the rooms that I am selecting. Okay, so what I'll do is I'll just give rooms option here. So basically, if I'm working in my architectural plan, I'll give rooms, but I'm working in my HVAC plan here. Okay, so what I'll do is I'll give spaces here. So how to give spaces? Simply what you can do is you can go to your analyze tab. Here you have option of spaces and zones. Okay, so in general, in our Revit architecture, what we used to do was we used to go to architecture and we used to give room separators. Okay, right now I don't want to convert this into room. I want to give it as a space. Okay, so this is a particular space, this is a particular space. Okay, so what I'll do is I'll go to analyze here and select space option. Okay, so this is a space of mine, space 1. This is a second space, this is my third space, and this is my fourth space, and this is my fifth space. Okay, so these are the particular spaces that I am dealing with: 1, 2, 3, 4, 5. Okay, now I want to convert all these spaces, or I want to separate, or I want to divide all these spaces into particular zones. Okay, so how will the zones work? So these zones will work according to the heat that, or according to the cooling that will be required throughout the day. Okay, so suppose this is my east, I guess. So this is my east, west, north, south. Okay, now suppose I'm in India and my sun will rise from this particular side. Okay, so this is east and my sun will rise from this particular side and it will set from this particular side. Okay. Now my HVAC system should be designed in a way that according to the time, so in the morning sun will rise from here, so sunlight will directly go here, right? Am I right?
Yes.
Yeah. So there will be higher requirement of cooling here if we are working in, so suppose we are working in Dubai. Okay. And suppose in Dubai your sun rises from east. Okay. I'm just hypothetically saying it. If suppose your sun rises from east here and it is very hot. Okay. And if we are designing HVAC system, we will require to use cooling system here in the morning, right? Because it will be very hot here. Okay, and till evening, at the point it is evening, the sun will reach somewhere here and this particular portion will be hot. Okay, so my HVAC system should be designed in such a way that this particular zone should be chilled in the morning and this particular zone will be chilled in the evening comparatively, right? So that is why we divide this particular zone, this particular spaces into zones. Okay. So suppose in the morning this particular zone will be cooler than this particular zone, and in the evening this particular zone will be cooler than this particular zone. Okay. According to this, our zones will be decided. Okay. So these are your HVAC zones. And if you want to give zones, simply what you can do is, first of all, you'll have to give spaces, and then you'll have to select these zones here, and then just select it. So one, so this is one of my zone, finish it. Okay, so this two will come under one zone, and then again I'll select zone, this and this and this might come under one zone. Okay, and according to that, you can see, you can just manage these things. Okay, HVAC zone 1. Okay, so this is your HVAC zone 2. And according to these zones, you can just manage heating. Now, suppose I want to create ducting here. Okay, don't worry about the commands right now. I'm just giving my systems here. I'm just creating a duct here. Okay, simply I'm creating a duct. Okay, it is passing through this, and one here, one here, one here. Okay, now I'll just give. Okay, so now here what I'll do is I'll just give some regulators here. Okay, so one of the regulator will be placed here, one of the regulator will be placed here. Okay, now here how it will work. So now suppose I want proper cooling in the evening here, so I will just increase the flow here, and here I will just reduce the volume of flow by using that regulator. Okay, and this part will receive, this particular zone will receive less volume, and this particular zone will receive higher volume, or the cooler air, you can say. Okay, and according to this you can just divide it accordingly, and that's why we divide this particular space into zones. I hope everyone is following.
Yes, sir.
Others?
Yes, sir.
Yes, sir.
Okay, Soumya, can you zones concept? Hello, Soumya?
Yes, sir.
Yeah, can you just explain this zones concept to me, HVAC zones?
Right. So basically, like to regulate the thing, like suppose, uh, okay, like one zone, if it is like if you want a particular temperature there, and other zone, if you want a particular type of temperature, we will regulate it accordingly. So we'll what do you say? That's all, sir. I'm not getting it properly. Like, I understood, I'm not able to explain. That's it.
Okay, fine, but whatever you said was right. Okay, so I will consider that this concept is
Voice
clear.
is very low.
Hello, am I audible now?
Yeah.
Yes, sir.
Is there a glitch? Should I rejoin? Hello?
Yes.
It's clear, sir.
Okay, so this is the basic concept of zone. Okay, so let's again select it and delete this. Now let's see the different things that are available in our ducting system. Okay, so first of all, for creating duct, what you can do is you can just go to your system tab. In your system tab, you have this option of duct. So select this duct and create one. Okay. Now suppose your alignment goes in this particular direction, so you can just draw it directly here. Okay, simple, no problem at all. Now again, suppose you want to manage the dimensions and suppose you want to manage the elevation. So simply select this duct. After selecting, you have this option. Okay, in this modifies tab, you have this option of width. Okay, so suppose you want to give a particular width. Suppose you want a width of, for say, 600 by height 500. So you can give it directly. And here you have option of middle elevation. So what is middle elevation? Basically, the whenever your duct is passing through, the elevation at the midpoint of that particular duct. So suppose you are if you are seeing a particular elevation of that particular duct, so the height of the duct divided by 2, the line will be passing through that, and that line, the elevation of that particular line will be your middle elevation. Okay, now suppose we have just this duct drawn, so I'll just select it and just go to a particular elevation. So let's go to a south elevation here, and you can see, so the line, okay, so this particular line will show you the middle elevation. You can see half of it is passing through the half of the height, and this is your middle elevation. Okay, and this elevation will be with reference to the level. Okay, so right now this duct is created with reference to level 1. So from my level 1, the elevation, whatever middle elevation is taken, will be from this level 1 to this particular line. Okay, so 2750 is the elevation here. So you can see the middle line that is passing through the duct is 2750 mm from your level 1. Okay, then you have your top elevation. So top elevation simply means the top portion, so elevation of this top portion, and your bottom elevation simply means the elevation of your bottom portion. Okay, in your previous versions there was no option, I guess, for your bottom elevation and top elevation. There was only middle elevation. So according to your updates, so if you are using 2020 and above version, it will be available for you, top elevations and bottom elevations. Okay, so this is the basic thing. So now suppose I want to create a duct with a middle elevation of 3200 from this level 1, and the size should be 500 by 500. So what I'll do is I'll just again go to plan here. Now I'll select duct. Okay, now I want a middle elevation of 3200 here. Okay, so I'll just select this middle elevation, or else you can just select this middle elevation, give it 3200. Okay, then you want 500 by 500. So I'll just select this as 500 width. Just a minute. 500 and height as 500. Simply draw it. Okay, now check it in the elevation view. You can see, so a height of 3200, I'll just delete the previous duct here. A height of 3200 with reference to your middle elevation from your level 1, and the size is your 500 by 500. Okay, I hope it is clear.
Yes.
Yes, sir.
Okay. Now this is about drawing your duct. Now there are various things that come along with duct. Okay, so the first thing is your connection. So let's see the type of connection. So first of all, let's see elbow connection. Okay, so basically if your duct is bending somewhere, so right now I'm selecting the duct here. I'm not worrying about the dimensions right now. I'm just creating a duct, and my duct is bending somewhere here like this. Okay, after bending, you can see directly, if I'm just creating a bend here, a direct connection of elbow is created here. Okay, automatically a connection of elbow is created here, and this is your elbow. Okay, this is your rectangular elbow. Okay, why this is rectangular elbow? Because if we check a cross section for this, it will be rectangular and it looks like an elbow. So that's why it is a rectangular elbow. Okay, if you just check it in 3D view, you can see it properly. This is a rectangular elbow. Okay, it is connecting from a rectangular section to a rectangular section, and it looks like an elbow. So this is your rectangular elbow. Okay, so this is your elbow connection. Then again, you have different type here. In elbow connection, you have different types, so you can just choose any one of it. And again, you have a type called as mitred elbow. Okay, so what is mitred elbow? So I'll just show it to you in image as well. So just a minute. Yeah. Yeah, you can see this is a mitred elbow. You can see a rectangular joint. Okay, so do you guys remember the mitre joint that we used in wall as well as in beam?
Yes, sir.
Yeah,
Yes.
so this is how it will work. So you can see the mitre joint is available here for a particular duct. Okay, and you can see I'm not getting a particular image here. It should be there. Yeah, it will look like this. Okay, mitre joint. Yeah, 90-degree joint, mitre joint. Okay, so this is your mitre joint, and these joints can be given to your duct as well in Revit. So simply what you can do is here, first of all, so I'll just leave this particular duct that we have created as it is. Now what we will do is we will just edit the type of this particular duct. Okay. See, there is one more way that you can do it. Select it and just change the type here. Okay, so it is meter. So select it and it will change to meter, and this will be created. But this is not a proper way to create it. Okay, you can see a meter join is created here. Fine, and shaded. A meter join is created, but this is not a proper way to create a join or to change the connection setting. So the proper way is what you can do is just select this. Okay, select your duct. You can see you have various types. Okay, but I want, you can see T's, taps, your connections and everything is given here. But in this particular elbow, I want a metered elbow. Okay, so what I'll do is I'll just change the routing preferences here. Okay, right now my routing preferences by default is circular elbow, right? So if I just create a duct, and if I just create duct like this, by default a elbow is created like this. Okay, your rectangular elbow is created here. But what if whenever I want to create a duct and whenever I want to give an elbow, I want a metered elbow. So for that, what you can do is you can just simply select this, go to your edit type, and first of all duplicate this. Okay, give it a name. So right now it is radius elbow. Yeah, okay, I'll just give it a name as meter elbow, mat elbow. Now here you have an option of routing preferences. Okay, go to edit routing preferences. Here you have various things. So elbow, right now by default elbow is selected as am rectangular elbow, but I want a meter elbow here. So whenever I want to provide an elbow to a duct, I want it to be metered. So what I'll do is I'll simply select this, drop it down, and here you have an option of am rectangular elbow meter. Okay, so I'll just select this. Okay, okay, and you are done. Okay, now you can see these will remain same. So previously in our walls, if we used to change a particular type, the existing wall used to change. Okay, but in this it will not happen. So now what you can do is you can create a new duct. Okay, create a new duct, and here I am giving an elbow, and you can see this elbow is created. Okay, I have not changed the type here. I'll just select duct. Okay, and I'll just drop it down and just select that mat elbow that I have created. Okay, rectangular duct, mat elbow, select it, and then create a duct. And you can see at the corner, at the position of elbow, your metered duct is created. Okay, again go to your 3D view. You can see your metered duct is available here. So this option was your routing preferences. So just like what you did to your elbow, you can do it for every connection that you will just encounter in your alignment of duct. Okay, so edit, go to edit type. You can just change your elbows. Then you can change your junctions as well. Okay, so we'll discuss in our upcoming part what is junction and all. Okay, you can just change the preference of junctions. You can change the junction types. Then again, you can change the cross connections as well. Then you can change the transition connections as well. So differential shapes connection as well can be changed. So everything that you are dealing with throughout the alignment of duct can be changed from this routing preferences. I hope it is clear. If you want, you can load the families as well. Okay, we'll see this properly. But this is this option of routing preferences, and it is most important option in your MEP ducting. Okay. I hope everyone is following.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now the next thing. Okay, so this is I hope the basic difference between metered connection and rectangular elbow connection is clear for everyone.
Yes, sir.
Okay. Now the next thing that we can see is your fittings. Okay, T fittings and tap fitting. So first of all, I'll just delete all these things. Becomes very difficult to manage this. Check none. Views. Delete. Okay. Now what I'll do is I'll just create a simple duct here. Okay. Let's create a met elbow type that we have created and create duct using that only. Okay, so I have created a duct, and here I want to give a takeoff. Okay, so suppose I want to give a takeoff here. You can see a particular type of connection is available here. Okay, so this connection, if I just go to fine and shaded, you can see this particular connection is called as your T connection. Okay, so you can see it is joining in as a T shape. So that's why this connection is called as a T connection. You can just again check it in 3D view as well. So this will be shown as a T connection. Okay, it is joining the T portions of your duct. This, and this, and it is by default forming a T. So this is why it is called as a T connection. Now again, if you want to increase one more connection here, right now it is joining 3 ducts. Now suppose you want to create 1 duct here as well. So what you can do is, here there is a symbol of plus. Okay, select this plus symbol and you can see an opening is available here. Now again, you can just select the duct and then give a duct here as well. Okay, simply check it in 3D view. You can see proper duct with proper connection is provided. Okay. I hope I'm not going very fast. Hello. Am I audible? Hello.
Yes, sir.
Yes, sir.
Okay, so I'm not going fast, right?
No, sir.
Okay. Okay. Now the next thing is your tap fitting. Okay, so this is your T fitting. Now suppose in this particular location, I don't want T fitting. I want tap fitting. Okay, so let's see how to do it. First of all, let's see what is a tap fitting. I'll just show you. Okay, so now you can see right now we have a T fitting, and this particular thing you can see the shape. This is a tap fitting. Okay, or this is also called as a shoe fitting or shoe tap. Okay, this is your beveled tap fitting. Okay, I'll just show you the basic difference between tap and T, and then I'll just go to this beveled thing. Now suppose here I don't want a T. Okay, I'll just create one more thing here. I'll just create a duct here. Okay, now here I don't want a T fitting. I want a tap fitting here. Okay, so what I'll do is I'll again change the type. So for changing the type, again you'll have to select this, go to your edit type option, again go to your edit routing preferences. Okay, so right now your preferred junction is T. So that's why that T was created. Now what if I want to create a tap? Okay, I want a tap, and you can see a rectangular takeoff will be there. Okay, apply. Okay, this will be as it is. There will be no changes here as we discussed earlier. Now what I'll do is I'll just select this. I'll just select this met elbow. Okay, and I'll just create one junction more. Okay, select this like it, and this. Now you can see here, I'll just show it to you in 3D properly. See, now you can see here a tap connection ends particularly here. You can see a connection is created, but it is not interfering inside this particular duct. You can see here, this tap connection is created or just touching the edge. Okay, it might be fitted properly, but it is just touching it. It is not interfering inside. But you can see this T connection, if you just select it, it is touching inside, it is going inside. Okay, so tab connection will be acting just like a tab. You can see a tab will just come outside wall and then give you water. Okay, it might not be penetrated deep inside the wall, or you cannot see it penetrating deep inside the wall. But here you can see in this T, it is properly visible that there is a joint in between these three ducts. Okay, but in your tab you can see it is just placed, or it is just it is visualized in a way that it is just placed outside the surface. Okay, so this is your tab connection and this is your T connection. Okay, now then again there is a common type that is used in your tab connection, that is your beveled tab or your shoe tab. Okay, I'll just show it to you as well. So now suppose I want to just change it. So by default, you can see a rectangular tab is created. Okay, but what if I want a beveled tab, or what if I want a shoe tab, just like what we saw in this. So if we want this beveled tab or shoe tab, so for that again you'll have to go to your routing preferences. Okay, again just go to your plan, select this particular type and go to edit type. Again go to your routing preferences here. Now here you have selected tab. Okay, so now let's see if we have option of our beveled tab here. No, we don't have an option. We have rectangular T and then we have rectangular standard takeoff. Okay, but what if I want a tab? What if I want a beveled tab? So for that, simply go to your load family. After going to your load family, first of all, in your US, you have this option of ducts. Okay, where is my duct? Yeah, you have this option of duct. So go to this duct. In ducts, you have two options, accessories and fittings. So my connections will come under category of, yes, will it be under category of accessories or will it be under category of fittings?
Fitting.
Right, it will be under category of fittings. So I'll just go to my fittings here. Now here, what shape do you want? You want your rectangular shape. What do you want? You want tabs. Again, you have this various options in tab. You want your bevel tab. Okay, select this bevel tab. Okay. Now again, you have selected tab option here. Now drop this down. You can see the bevel tab as well. Select it. Okay. Apply. Okay. Now you have changed your routing preferences here. Now, whenever you create a duct, so after changing it, so if you are using this met elbow option, so create a duct and create a junction like this. Okay, and whenever you will create a junction, you can see you will get a bevel tab here or a shoe tab. And this tab, you can see the nosing or the slope is here. And this slope by default should be always in the direction opposite to the flow. So suppose my air is flowing in this particular direction, so my nose should be like this. Okay, to reduce the friction. So this is placed in this particular way to reduce the friction. Okay, suppose it is in this particular way, there is a chances of friction and there are chances of failure of this particular duct. So place it properly in this particular direction only. Okay, so this is your beveled connection or beveled tab. Okay, so what type of connections did we see? Can anyone just enlist it? Just enlist it. Yes. So what did we saw till now in connections? What are the different type of connections that we saw? Hello.
Yes.
So what are the different type of connections that we saw till now?
Rectangular elbow, metered elbow, T
Right.
connection, tap
Right.
connection. Tap is or otherwise known as shoe connection also.
Okay.
And then elbow, the last one. I mean beveled.
So beveled and shoe connection is one and the same thing. Okay.
Hmm.
Okay, I hope everyone is following.
Yes, sir.
Yes,
Just
sir.
let me know, okay? If someone is not getting something, just let me know. Okay, so these are the basic things. Now again, there is one more thing that you can know, that is your transition. Now suppose these sections are same, okay? So this is also a rectangular duct, this is also a rectangular duct, and we are joining rectangular ducts only. Now, for example, we want to join a rectangular duct to a circular duct. So in that situation, let's see what happens. So first of all, I'll just go to my systems here, select duct. Okay. After selecting duct, first of all, I'll just create the rectangular duct, normal duct that we are working right now. And here in this particular location, I want a, for say, circular duct. Okay, so simply what I'll do is I'll just select this option and select a circular duct. Okay, and just a minute. Again, I'll just create a duct here. Okay, and I'm not finishing it right here. Okay, I'm not just escaping anything. I'm just choosing a right duct. Okay, so right now it is round duct. So I'll just again create a rectangular duct from here. Okay, and after creating, you can see a join is visible. And if you just check it in 3D view properly, this type of connection is provided. Okay, so that means this connection is transiting. Okay, it is transiting means it is changing from your circular to your rectangular section. Okay, and that's why this particular connection is called as your transition connection. Okay, it is transiting, right? It is changing from your circular to rectangular, or maybe your rectangular to oval. So whatever shape it is changing itself. Okay, it is changing the cross section, and the connection that is helping it to change is your transition. Okay, this is your transition. Now again the same thing. Suppose you are working in your rectangular duct only and you are reducing the size. Okay, so I'll just go to mechanical here. Again, I'll just create a rectangle. Okay, I'm just creating a duct, rectangular duct. And again, this is 500 by 500. And now I'm creating a duct of, for say, 150 by 150. Okay, 150 by 150. You can see if I'm creating it like this, there is a change of your diameter or change of your cross section here or change of your size. So you can see a proper connection is provided here, and this connection is called as your transition. You can see I'm rectangular transition angle 45 degree. If you want to change angle, you can change angle as well. If you want 15 degree, you can get a 15 degree transition as well. If you want a different angle, you can get a different angle, 30 degree triangle. If you want 45, you can get 45 degree. Okay, so this is your transition connection. Again, there are two types in this transition connection. The first is concentric type. So this is our concentric type of connection. So suppose if you just go to any of the elevation here. Okay, so right now I am in my mechanical plan. So if you just go to the south elevation here, let's just delete everything else. Okay, so this is my connection. Let's go to the south view. Where is my connection now? Okay, it might be somewhere here. Okay, I'll just create a new one. So I'll just create inside this only. I'll just select a duct. Okay, simply I'm creating one like this. And here I'll increase the diameter to 500, sorry, dimensions to 500 by 500. Okay, and I'm creating like this. You can see a transition is available. Let's check it in south view. Yeah, you can see a transition is available. Now here, rectangular. Okay, now here you can see this is a concentric, or this center, the center of this particular duct is, and center of this particular duct are in alignment, right? But sometimes what will happen is, I'll just delete this, or let's copy this again. Okay, I'll just copy this and I'll just take a copy in here. Okay. Now here, sometimes what will happen is this particular duct will be eccentric. Right now it is passing through center, but this particular duct will be eccentric, or this particular edge will be aligned to this particular edge. Okay, so let's see how things work at that particular situation. So I'll delete this transition. I'll use my align option here. I'll align this to this. Okay. Now what I'll do is I'll just select it and just connect it right here. Okay, and you can see a transition is provided, but this is quite eccentric. Okay, so this was your concentric and this is your eccentric. So this is your concentric transition and this is your eccentric transition. This is because this particular duct is eccentric to this particular duct, and that's why this is an eccentric transition. Again, if you want, you can change the angle here. If you want 15 degree, you can get 15 degree. I hope it is clear transition.
Yes, sir.
Okay. So what are the basic connections that we have seen till now? Yes. Rajiv, can you enlist the connections that we have seen till now?
Yes, sir.
Yeah, please.
First, we saw about elbow type, in which rectangular and metered.
Good.
Then we saw about the T shape.
Hmm.
In there, we also saw beveled shoe shape.
So what is beveled and shoe shape? What is the type?
In T shape, the connection is also meeting the all the both pipe, but in beveled shoe shape,
No.
they
What I'm
don't
asking is
intersect.
under what category this beveled and shoe type comes?
Oh,
Tap fitting, right?
that's type fitting.
Okay. And
After
then,
that, a transition type we saw.
and what is transition?
Transition if two pipe have different dimension, so
Hmm.
there we will provide transition connection.
Okay. Okay, so I hope this concept is clear for everyone. Yes?
Yes, sir.
Any doubts, any questions, any queries?
No, sir.
Okay. Okay, so